Space travel is hard.
All sorts of challenges we will face on deep space missions.
This country of the United States was not built by those who waited and rested.
Astro, go. I don't go.
NASA's recent revelation of a staggering $93 billion budget for its lunar colonization endeavor, known as Artemis, marks an exciting new era in space exploration. This ambitious mission transcends a simple lunar visit, aiming to lay the groundwork for a sustainable human presence on the moon, potentially paving the way for a moon colony. In this discussion, we will delve into the intricacies of NASA's visionary plan, the formidable challenges it confronts, and the potential ramifications for humanity's quest to colonize the moon. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. In case you haven't been informed, space exploration is making a comeback. Depending on your information source, venturing into the cosmos can have various purposes, ranging from mining rare minerals to securing the future of humanity. However, NASA is adhering to traditional scientific research and has embarked on Project Artemis, essentially creating a new space habitat reminiscent of the International Space Station, but this time on the moon. Artemis aims to enable astronauts to conduct experiments and research on the lunar surface, as well as test the feasibility of interplanetary living, with the eventual goal of sending astronauts to Mars. Handling this celestial construction is ICON, a 3D printing specialist based in Texas. In November 2022, ICON was awarded a $57 million contract to develop 3D printing technology for constructing housing and infrastructure on the moon for Project Artemis. Staying true to the Greek theme, ICON aptly named their mission Project Olympus. While we've seen plenty of speculative CGI images of lunar or Martian bases over the years, this project is poised to make these visions a reality. The first astronauts are scheduled to return to the moon in 2025, and ICON is set to demonstrate its technology in 2026. According to Jason Ballard, co-founder of ICON, the ultimate goal of this contract is to achieve the first construction by humanity on another celestial body. Once the lunar infrastructure is ready, it will include housing for astronauts, roads, and launch pads. Pause for a moment. Didn't 3D printing emerge as a groundbreaking technology approximately a decade ago, with the promise of revolutionizing both the construction sector and the creation of various objects, from housing to chocolate bars? However, it appears that over time, it lost some of its initial momentum. If it didn't quite gain widespread acceptance or thrive on Earth, what makes it a viable option for lunar application? To provide insights into this matter, we require an expert in the field, someone like Moataz Atala, who leads the AMP Lab, or the Advanced Materialism Processing Lab, a research group primarily dedicated to understanding the materials science of advanced manufacturing, particularly within the realm of 3D printing. While 3D printing may have somewhat receded from the public's attention in recent years, it doesn't mean that the technology hasn't made substantial advancements. According to Atala, critical improvements in 3D printing began early on, and with the enhancement of laser technology, we witnessed remarkable progress. Robotics has also played a crucial role in the mobility of components. Presently, we observe 3D printed components being applied in various fields, including medicine, industry, and even space-related endeavors. As the technology has evolved, there has been a significant expansion in the range of materials that can be 3D printed. In the past, plastics dominated this landscape, but researchers have developed machines capable of printing in novel materials like concrete and metal. The increased strength of the final products has resulted in a substantial shift in design methodologies, which is particularly intriguing within the construction domain, even though it hasn't fully taken off there. All of these advancements have piqued NASA's interest. Atala also pointed out that in the past, when an architect designed something highly intricate, such as the Sydney Opera House, the focus was primarily on how to manufacture such a complex structure. However, 3D printing introduced a new concept, designing for functionality. The intricate complexities of manufacturing can be set aside as the technology can manage that aspect. The primary consideration becomes the intended purpose of the component or structure. While there might be considerable optimism surrounding this technology in lunar applications, the situation on Earth doesn't appear as promising. The global economy is still grappling with the economic repercussions of the pandemic. The United States faces the ominous threat of national debt defaults, with officials warning of dire consequences for all Americans, including increased interest rates on home and auto loans and higher credit card payments. This is especially concerning given that a substantial portion of U.S. households already depend on credit cards to cover their living expenses. In December, the conventional stock and bond investment strategy recorded an average loss of 25% over the past year. Nevertheless, experts have found that tangible assets, such as art, can appreciate more effectively than real estate and stocks during periods of high inflation. Masterworks provides an opportunity to invest in high-value art pieces created by renowned artists like Picasso and Banksy, all at a fraction of their full price. Icon is a great example of how 3D printing technology is getting better. They started in 2017 and quickly became a top player in making large 3D structures. By 2018, they made the first 3D printed house in the United States. Last year in October, they began making 103D printed homes in Austin, Texas. At first, Icon got some money from NASA to work on 3D printing ideas. They even created a prototype base called Mars June Alpha, which astronauts used for training on Earth. NASA was so impressed with their approach that they gave them a big contract to build on the Moon. If you're still wondering why NASA is betting on this technology, think about the competition on Earth. 3D printing had to prove itself to a world where traditional construction methods, rules, and designs are firmly established. But on the Moon, there aren't many other options. Any construction site on the Moon has to be self-sustaining because it's impractical to send a lot of equipment or skilled construction crews from Earth. This is why 3D printing is the best solution for building on the Moon. So let's give a big round of applause to 3D printing as it gets ready for its mission to the Moon. However, there's one last thing to consider. Here on Earth, gravity plays a vital role in the 3D printing process by allowing materials to be neatly stacked on top of each other. However, things work quite differently in outer space, as explained by Professor Atala. In microgravity, there's no gravitational force to hold things in place. If you attempt to deposit something, it tends to float away because there's nothing anchoring it down. Professor Atala's team devised a tool used by the European Space Agency to craft items like screwdrivers in space. They used a metal wire to guide molten material into position. Placing the metal wire at the convergence of 3 mirrors resulted in a process humorously termed a death ray. This death ray melts the wire, and the molten material can be employed to stick together droplets due to the surface tension of the molten material. The primary objective of 3D printing on the Moon is to avoid relying on materials from Earth. The Icon system will use lunar regolith, which is the layer of lunar surface dust and broken rocks mixed into a mortar. This material will be layered by the printer to construct structures. To make these layers adhere to one another, a resin or chemical can be used, which gets cured by the available ultraviolet rays on the Moon's surface. This process resembles the one employed to solidify dental casts at a dentist's office. Nevertheless, there are hurdles and uncertainties. The Moon lacks an atmosphere, and the constructed structures must shield against harmful radiation, temperature fluctuations, and potential impacts from small meteoroids or asteroids. This approach is a long-term endeavor, and it might be at least 50 years before we witness complete Moon colonies constructed using this method. Although the advantages for construction on Earth may not be groundbreaking, this approach could encourage more sustainable construction methods. Professor Atala underscores the importance of sustainability, which hinges on using locally available raw materials. This could be particularly beneficial in regions with limited access to traditional building materials. It might also promote the recycling of construction waste. The greatest challenge for the broader adoption of 3D printing in terrestrial construction lies in proving its worth to a well-established industry. While construction in space may not have a direct impact on Earth's construction, it serves as a compelling demonstration of the technology's capacity to produce intricate structures.